Alright, so the first thing I'm going to do is I'm going to do the working above this, and I'm trying to explain what I'm doing each step. I actually got a really good question before. How do we know we're dealing with uncertainty? How do you know the focus of the question is uncertainty? That is actually a really good question. It's something I've left off or haven't really spoken about taking for granted. Mason, how do you reckon I know that I'm dealing with an uncertainty problem here? Because nothing about the words say uncertainty.
Because of the 0.05.
Yeah, so because I've provided us with measurements that have uncertainty, I know that I'm requiring to deal with uncertainty in my problem, correct? I also haven't given us units, which I should have done. I'm just going to make it centimetres, but I should have done that initially. Now, anytime I'm dealing with an operation between two numbers with uncertainty, if you're ever unsure, there are a few scenarios where you don't actually have to do percentage uncertainty. That's when you're dealing with the same unit and you're adding or subtracting. But if you're ever unsure, just convert it to percentage uncertainty. Any operation with uncertainty, convert it to percentage. So the first thing I need to do is convert my 0.05s into percentage uncertainty. So to calculate my first one, I go 0.05 divided by 23.0 times 100. That's my first uncertainty, which gives me 0.19, I think. Was it 19?
Oh, I got 21.
21, sorry. 22.
22, yeah, because you rounded.
Yep, thank you, that's good. And 0.05 divided by 15.5 times 100, and that gives me 32%.
So is that the percentage uncertainty formula?
For each value, yeah. Yep. So that's measured uncertainty, the uncertainty I found, divided by the measured value,
Yeah.
times 100.
Okay.
So remember, this relates to my 23.0, and this relates to my 15.5 measurement. So now I rewrite my sum, where I've got 23.0 times 15.5 plus or minus, in brackets, 0.22% plus 0.32%. Happy with that step? I just complete the operation and add my percentage uncertainty, and that leaves me with 356.5 plus or minus 0.5, that's not a 5, that's a 3, 54%. Good with that? And my last step is simply converting my percentage uncertainty back, and that should be centimetres, by the way, centimetres squared. My last step is simply converting my percentage uncertainty back into absolute. So do that. Up here, I do the reverse. I now know that 0.54% divided by 356.5 is equal to my absolute uncertainty. How do I get that by itself? Yeah, transpose or rearrange. For those of us who can do that in their head, do I have to do it? Do you want me to step it out, or can we do that in their head?
Step it out.
Times both sides by 356.5. We need to get that at a percentage form. How do I get that at a percentage form? Instead of representing that, that is 0. That divided by 100. And I shove that into my calculator. And I get my absolute uncertainty equals 1.92, was it?
1.93.
1.93. 1.93 centimetres squared. And then I shove that back into my final. So I get 356.5 plus or minus 1.93 centimetres squared. With that, just to run you through that process again, I convert it into percentage uncertainty. I complete the operation, I add my percentage uncertainties together, and then I convert it back out of percentage uncertainty. We will keep practicing that. I know it's tricky. Once you understand it, and there are some things to remember that help. So remember, with science, we always assume worst case scenario. That's why we add the percentage uncertainties. We convert it into percentage uncertainty because we don't like we can't deal with things across units. And if we did like a multiplication of these numbers, if you multiplied 0.05 times 0.05, you're going to get a really, really small uncertainty. Is that what we want? That's what we want when we're testing, but we don't want to fudge our way to it, do we? So that's going to give you an unrealistic uncertainty. So trying to keep those things in mind helps you remember the right course of action. Good? Alright, let's talk about types of error.